Hi folks, this is tutorial number 25 and I'll be discussing the use of rigid body dynamics simulation in the Catia 3D Experience platform, release 2025x. What I want to show you is that if you have a problem which involves cable joints and surface friction in the same problem, that's going to be problematic. In fact, in tutorial 24, I showed you whenever you have a prismatic joint and surface friction associated with the interaction between the joint and the two joints or the joint, it's not going to work. So friction will be ignored. Here, I will do a closely parallel problem where you have a cable joint, and you'll see why this is ultimately related to tutorial 24. So as an illustration, I will take a problem like that. This is coming from second year dynamics class, uh, textbook by Hiebler. And we're going to look at the case where there's no surface friction between these blocks and the ramp, and one which there is a surface friction. So let's assume that they have the same weight, 10 pounds, and the mass is calculated to be this. And here's the gravity constant in feet per second squared. Now I'm going to take two cases. The case where mu k equal to 0, no friction for both of them, and then come back and show you what happens when mu k is equal to 0.1. Now, basically, hand calculation using Newton's second law applied to the block A and block B, where sum of all the forces equal to mass times acceleration along the ramp, writing it for block A and writing it for block B, and realizing that the tension in the rope, assuming that this rope is inextensible, the tension in the rope is constant, and pulley has no mass, so that what you do is with mu k equal to 0, no friction, hand calculation will give you the acceleration of 5.89 feet per second square for both blocks, actually, in this problem, and that's going to be the tension. Now, hand calculation also give you a different acceleration for each of the blocks. They're the same, of course, which is equal to 3.690. That's to say that's going to be smaller than the other. Now, uh, here's the way I'm going to do that. I will create a two prismatic joints associated with the block on the left and block on the right. The prismatic joints are going with these ramp, one between the orange block and the ramp, the other one between the yellow block and the ramp. And once we have that, we're going to create a cable between them. Later on, I'm going to create a cable between them, a cable joint between them. And of course, I will do the contact to indicate the contact coefficient between the surfaces. You will see that with the cable, the results are not going to be correct. And we come to this slide later on. Okay, we all come to this slide later on. Dimensions don't matter here, except that I will respect the fact that this is 30 degrees, the other one is 69. It has nothing to do with the problem, but that's how we're going to do that. Let me insert my ramp first. Right click, insert 3D part. That's going to be the ramp. Okay, so let me use properties, change this thing to ramp. And ramp. All right, let's go ahead and make it. Okay, so on that vertical plane, I will sketch. I'll sketch a broken line like that. This eventually becomes a ramp. Okay, let's put some angles here. This one is 30 degrees. And the one over here is 60 degrees. Exit. There we are. Let me go back here, and just for the sake of illustration, I'll put a dimension here. See, my units are feet, so I'll make this thing about 6 feet. Yeah, 6 feet. Has nothing to do with the problem, but I will do it. Okay, good. So there we are. So exit, and then we're going to pad it by 1/2 inch. There we are. Okay. So now we're going to go insert our first block. So all the way to the top, right click, insert 3D part. And they're going to be identical blocks, so the mass is the same. Therefore, I make one of them and then create the instance of the other one. So let me change this thing. So this is going to be a block. I'll call it uh, how about calling it orange block? It's totally unnecessary because they're identical. But I'm going to bother making two separate ones. Copy, paste. Okay. Let's go make it. On that vertical plane, I will sketch. Something eventually becomes that block on the ramp. Okay. Let me see for a second. Let me exit and then pad this thing by 0.5 feet. There we are. And I'll change the color here also. It's going to be the orange one. All right. Then the other one is exactly like that, but it's simple enough that I can go make it. Right click, insert, 3D part, yellow block. Make it. Double click on this. So on that vertical plane, I will sketch. I'll put the other block over here. It is same size. And if you have any doubts that this is bothering us, so we can actually put a dimension here. I'll make this thing 0.5. And I'll make this thing 0.5. Okay, exit. Pad it by 0.5. 0.5. Oops. Try it again. 0.5. There we are. Let me change the color here. I'll change that thing to yellow. And just so that there is no ill feeling, I'll go back to this pad. I'll make that thing the size 0.5, 0.5, because later on I'm going to specify the weight on it. The size of it doesn't matter, but I'll do that. 0.5. Okay, and did I do that? 0.5. And the other fellow is also 0.5. Good. Exit. And we're all set. Okay, so we go all the way to the top. We can apply our okay, so first thing we're gonna do is fix this ramp. So under assembly, engineering connection, there's a fix. I'm gonna fix the ramp. Okay, and then I'm gonna create two prismatic joints between one between the orange block and the ramp, and the other one between the yellow block and the ramp. So let's go ahead and look for prismatic joint right there. All right, and there are different templates that you can use. I will use this one, edge, plane, and for if you have to control it, I use the distance between two planes. So this is the one that I'm going to be using. So how about that edge and this edge? This plane and that plane? And for the distance is going to be that back edge and this back edge. Okay, and then say okay. What I'm going to do, by the way, is I'm going to move these things a little bit further down. I want this thing to move a little bit. So manipulate it. I will translate this thing in the direction like that, so it looks nicer. Good. Okay. Let me keep it like that. So we already have one prismatic joint here. Then I'll do another one between the yellow block and the ramp, another prismatic joint, same template. I will use this edge and that edge, this plane and that plane. And for measuring, controlling, if necessary, I'm going to be using that back face and this back face. And say, okay, good. So we have two prismatic joints. Good. Now, of course, these can be independently moved as prismatic joints, but I'm not going to do that. I'm going to create my cable joint. So let's go ahead and create our cable joint. Now, the cable joint, you will not see it among this list. You go to engineering connections. Incidentally, I did, I think it was, if I'm not mistaken, tutorial 23 in this playlist dealt with cable joint in 3D Experience. But anyway, let's find the cable joint in this list. Here's the cable joint. Notice that it's asking for two prismatic joints. This is a compound joint made of two prismatic joints. That's the only thing you can select. Okay, so I'm going to select this prismatic joint and that the other one. Okay, that's fine. Good. So we have a cable joint between these two. As one moves, for example, the orange block moves down. Excuse me. As the orange block moves down, it should pull the yellow one. Now, if you go back to the cable joint, you see that there's a ratio here. Okay, this ratio means, or do they have the same movement, or one moves faster than the other one, etc. We want them to have the same movement. Okay, that's fine. Say fine. Now, we are pretty much done here. So let's go ahead and create our mechanism. We go to mechanical systems design. Create a mechanism representation. Okay. Now these arrows, you may have to flip them because the direction of the motion of the two may not be quite what we want. But anyway, let's keep it like that and we'll worry about it later on. So let's see now what we got here. Mechanism manager is good. One fixed part, two prismatic one, which have been turned, because they're compound, they have been turned into a cable joint. Now, the only thing is that the direction of the motion of this may not be what we want. We'll find out. So if you click on the mechanism player, we'll find out whether it's going to work or not the way we want it. Otherwise, you're going to have to flip some of these. So if you take this sliding bar and drag it, this is not what we want. See that? It's not what we want. Okay. Of course, the same thing is going to be with the other fellow. It's not what we want. So reset. Go back to that prismatic joint or cable joint. It doesn't matter. And let's flip one of these. So we can put the cursor there. Let me close that. Cancel that. Put the cursor here. Right click. Notice that you can flip it. Just flip this thing. Flip it. I don't know whether I flipped it or not, but anyway, now let's go and check it out. Go back to the mechanism player. So at least they look correct. You can see that they look correct. But what I'm going to do is when this thing goes down, the other one comes up, etc. The only thing is that the magnitude of these is not what I want. So let me go and try to change these things. So let me see now. Maybe this one is okay. That one is for this orange one. So let me uh, move this into a different location. So maybe let's send it to 0. See where it is. Fine. Okay, so the only thing is that the location of this is really not what I want. So let me go back here to that prismatic. It's that distance, right? So let me move this thing to maybe 1 foot. Ah, no, no, cancel. -1. Okay, say okay. All right, fine. Now we go to the mechanism player. Yeah, that's really what I wanted. And also this range, I wanted this thing later on to go down. It will go down, but that's okay. So good. So notice that in the Catia program, by changing the sign of that cable ratio, you could control these things, but it doesn't work here. If you put a -1, for example, here, it'll go back to 1. See, it goes back. You cannot change the sign here. You have to go and play with these directions. Okay, let's try it again. Yeah, that's good. That's good. Reset. Okay, so let's update. Now, what we want to do is assign weights to these pieces. So we go to here to widget, or not widget, weight definition. Everything is red. So this is going to be the ramp. The ramp is totally irrelevant as far as the weight is concerned because it's stationary, but you have to give it something. So click this hyperlink to compute its weight, or click this hyperlink to assign, declare. Click on it. Right now, everything is 0, so you make it out of steel by selecting this checkbox, and then everything is going to be made out of steel, but of course I can change that. I can change that to, okay, I can leave it like it is, or change it, but I'll leave it the way it is. Close that. Let's select this orange block, double click, declare weight, default properties of steel, and I'm going to change that thing to 0.31 slugs. 0.31 slugs right there. Okay, and then close it. This becomes blue, and now select this again, declare. Really doesn't matter. 0.31. So they both have the same mass. Okay, good. Everything is green now. All right, that's pretty much it here. So now we're going to go to, yeah, now we're going to go to, let me see for a second. Notice that later on, I'm going to come and put some contact connection there later on, because the only way you can introduce the coefficient of friction is you have contact, but I'm not going to do that right now. Right now, we don't have contact. That's fine. So we go to mechanism design, mechanism systems experience. Fine. Okay. All right. Let's actually we're gonna apply gravity excitation right there. See that gravity excitation? You click on it and you say okay. So gravity excitation is created. 32.2 is the gravity constant. Now we're going to create some sensor because we want to find the acceleration of these 2 points. They better be identical, and they better be that number that I got. So probe, this is going to be one of them. I'll call this thing yellow or orange, just so that I can keep track of things. Okay. And then another one. Say that point. I'll call it yellow. Mhm. All right, good, good. So we have two probes here, and we're going to create a dynamic scenario. Put the gravity in there, put both probes in there, and oops, let's go ahead and run it for let's run it for 1 second, see what happens, and then we come back and make it bigger response. Now notice that they have two choices: DASL or symplectic oil. Let's try DASS SSL first. Okay, so put the cursor here, right click and run it. Okay, maybe I should make that thing a little bit shorter. I'll make that thing maybe 0.5. Let's run it now. Okay, I'll make it 0.7. I want to make it look good. That's pretty much it for now. Run it. All right, very good, very good. Now, let's look at the results. So here is the view scenario results. You check everything, unselect everything, and look at the magnitude of the acceleration for the two probes. One of them is for the orange one right there, acceleration, linear acceleration, right there. This is for the orange one. See, orange. And then the other one is also linear acceleration, but for the yellow one. Plot it. Needless to say, they're going to be the same. Needless to say, they're going to be 5.89 and hallelujah, 5.89. Good. Excellent. So now, by the way, let's change the integrator. Let's change the integrator to the symplectic Euler and run it once again. I don't anticipate any problem. You're going to get the same thing, same results. Go back to scenario results, deselect everything. Here is your linear acceleration, not this linear acceleration. And for the yellow one, linear acceleration right there. Same value. Everything is the same. Good. Very good. Now, the question becomes, I don't have any friction here. The question becomes, what if I want to put friction in there? So the way we know how to handle friction is we go back and find contact and specified contact coefficient. So let's go back here. Let's go back here to mechanism. Oops. To go to mechanism, you can do it from here, switch to mechanism, or you can go here, switch workbenches. Now here's a contact. See that? Contact connection. You click on it. We need contact between the orange and the ramp and between the yellow and the ramp. So add, select the orange one, another one, add, select the yellow one. That takes care of this. And group two, add the ramp. Okay. So now we have two options here. Two options. One is restitution. One of them involving this tab where you specify a coefficient of friction. Let me do both of them. So here is 0.1. Just so that we don't miss anything. Oops. 0.1. Good. And also do this one. Surfacic contact 0.1. It's already 0.1. Good. So we have created our contact. Now remember, when you do that, this contact is not going to appear in your manager. You see that? It's not checked because I did it after I created. So make sure you add these. So now, presumably, we have cable, and we have contact right there. So look at the joints. We have cable made of these two prismatic joints, and we have contact. Okay, good. So let's go ahead and find out what will happen if we run it. So let me double click on scenario, double click on the scenario. Okay, right click, force compute. Okay, let's check our acceleration. Deselect all. linear acceleration of the block, linear acceleration, and linear acceleration for the yellow one. Look at the number. Look at the number. Made absolutely no difference. Okay. The reason it makes absolutely no difference is that if you go back to tutorial 24, you see that even when there is no cable, when there is a prismatic joint, even though you may define coefficient of friction between the two pieces, if you have a prismatic joint, it'll totally ignore that that value of the coefficient of friction. So cable joint in the way we're using it here is totally useless because you cannot incorporate friction. You might say, well, in the case of tutorial 24, you said, okay, can I delete the prismatic joint and run it? The answer is yes. But the problem is that if you delete the prismatic joint, you cannot create a cable. So in reality, you have to delete the cable. If you delete the cable, under gravity, these go in different directions. Well, you can check that, for example. If you go back here, if you go back to your mechanism, click on the mechanism manager, do not include cable, do not include prismatic joint. It's going to come back with a message saying that, hey, something depends on this prismatic joint, the cable. You can't do that. So I can delete, for example, the cable one. I can delete the cable one. That's gone. The prismatic joints are still here, still will have absolutely no effect. They will go in different direction. Okay? And friction will not be taken into account either. So if you delete these and just leave the contact there, it will run, but these will go in different directions. Let's run there. And of course, the accelerations are totally meaningless. You're not going to get anything meaningful. Okay, the moral of the story is that, look, if you have a prismatic joint, this contact will do nothing. Okay? And I think it's probably helpful to watch tutorial 24 also.